Well, it's time. It's time that we upped our soldering game. So far we have built a couple of small expansions for the Amiga computers. Those have all been for the A500. This time, let's build something for the A1200. Let's build an accelerator. Let's build a TF1230. Or perhaps what I should say is let's build some of a TF1230, because this card here that I got from SparxUK, well, when he was ordering them, he did a batch and got the factory to fit out the bottom for us. Well, more or less. There are two little resistor arrays that need to go on there and the crystal that needs to go there. And because it's been a while since I've done any soldering, been a couple of months, normally I would do the CPLD first because it's, you know, the tricky bit, but just want to warm up a little bit, and I think what we'll do is populate these couple of spots on the bottom. That'll get the whole bottom of the card finished, and then we can concentrate on what's up here. And being the absolute legend that he is, Sparx, when I was buying all this stuff off him, he very kindly separated out all the different components, labelled what they are, so it's just going to make life putting this together so much easier. There's the 1230 crystal, there's the 1230 10K arrays. Yeah, that says 1260 there. We're just going to ignore that bit for today. So let's start with this component here. This is one of the 10K arrays, or resistor arrays. That's it sitting there. Now there is a pin 1 marking on the silk screen, or at least I think that's what that is. But I don't see anything marked on this to denote pin 1. I don't think it actually matters what orientation this goes in, because I'm fairly sure this is just like 4 10K resistors in a line there, just in the one package. So the orientation shouldn't really matter. I'll put a little bit of flux on the board. We'll try and position the component. Just tinned up the iron. Let's see about getting it stuck down. Yeah, definitely out of practice, aren't I? Doing that big CPLD is going to be fun. I do need to tidy that up, and I will do in a minute. So let me see if I can flow the other side of it any better. I guess just a matter of too much solder on the iron. It's amazing how you get out of the way of doing this so quickly. But it is on there. It mightn't be the straightest, but it is stuck down. Just tidy this up a wee bit so I can get a better look at what I've done here. So yeah, it's on there. It's just not very good, is it? It's not straight. And with my rustiness at this soldering game, I've damaged a little bit of the solder mask on one of those traces there, albeit a bit of solder itself has made its way onto the copper, so it will be fine. But the component is not sitting right, so let's crack out the hot air. And this is why I wanted to start with a small component like that, rather than tackling the CPLD, because I knew I was going to be a bit rusty. But hopefully if we just heat this up here, it will pull itself into the correct location. There it goes. Just let me inspect that again. And yes, it is now sitting pretty. So let me do that one. And since I'm on the bottom of the board, I may as well put the crystal on as well. Get those done, and then we'll have a go at that CPLD. Right, that's the 3 components fitted. Not the neatest job I've ever done, but hopefully that's enough to kick off the rust because it's time to tackle the CPLD. So this thing, I am a little bit nervous here putting this on, I have to be honest with you, after making a bit of a mess of those very simple components on the underside. But we're going to have to do this sooner or later. This is the biggest one of these I've fitted to date. All the CPLDs on the other boards that we've built have been considerably smaller than this. Well, it's the same pitch of pins, there's just a lot less of them, so they're easier to line up. And that's the first thing I need to do. So I'm going to try and do that off camera, line it up, and like I've done with all the rest of these sort of things, I'm going to put a bit of Kapton tape over it just to hold it in place while we start to solder it. You know what, actually, I'm not going to put tape on it because I think I've got it lined up pretty much perfect there. So I'm just going to put a little bit of flux just on those first couple of pins. Then we'll take the iron, which I've tinned up here, and we'll just see if we can get even this corner attached. I don't care if there's bridge pins or anything at the minute, I can sort that out later. Alright, you seen it move a little bit there, but it is definitely stuck down in that corner. So if I can get it orientated again, and then get that corner up there stuck down, well, that should be it in place. So I think that's pretty good there. Again, just going to put a little bit of flux on those first couple of pins there. A bit more solder on the iron. Again, that's way too much, but I think that's our CPLD orientated correctly. So now there's nothing to stop me just putting flux on this and flowing everything. Maybe off by a fraction on this side here, but I think it'll be okay. So we just load up with plenty of the flux. Then we can tin up the iron and just go to work. I actually don't think I have the iron hot enough there, because the solder is solidifying on those pins rather than, you know, flowing along it. In fact, you can't see that very well from that angle, can you? Bit of a blob up that end there, but I can very quickly sort that out with a little bit of wick. And hopefully that is that side done. So I'm going to do the rest of it, and then it'll just be a matter of doing the two RAM chips and these parts. Well, that's all the surface mount stuff to do. There's still quite a bit of through hole to get done. Well, that's it on. I give it a bit of a rough clean, still needs another going over, but I'm pretty pleased with that. There was a couple of spots there where, again, the solder mask came off those traces. I think it's maybe the tip on that iron. I think it's maybe not the best, to be honest with you, and it's scratching off the solder mask there just as I'm dragging across, but again, I've just tinned that up there. There's a wee bit there as well. But the chip itself, it is on, and it's pretty well aligned. That side is a wee bit rough in terms of alignment, but I have buzzed it all out, and it all seems to be making continuity okay with no shorts. There is one really good way to test it though. We can try and program it. So I think what we'll do is crack out the Raspberry Pi and do exactly that. Okay, Pi 3B set up here. This is the one I use for all the programming. It just has these wires permanently attached to it for this very purpose. We're going to be taking power for the CPLD from the Raspberry Pi, 3.3 volts. This wire is all set up as we need it, so that just goes in there like that. And I'm going to hold it with a little bit of tension. Then on the PC, you can see that I've connected to the Pi here over SSH, and we've got the command ready to go there with the TF1230.jed file at the end of it. So let's hit return and hopefully this works. Yep, success. One CPLD programmed. I can pull that off. Time to just get the rest of these components on. The next thing I think I'll do then is fit the memory. We've got these two chips to put on, there and there. Now there are options for the memory on this board. You can either fit 64 meg or 128. We're just fitting 64 megabytes to this card here. My other Amiga accelerator, the ACA card, it has 128 meg of RAM on it. And to be perfectly honest with you, for all I use the Amiga 4, just for games, well, I dare say it's never really used any more than about 4, maybe 8 of those megabytes. Maybe, you know, when playing one of the big point and click adventures. So 64, it's going to be loads. These are really easy to line up as well. The pin pitch here is easily twice what it is on that CPLD. So move that one out of the way. That's lined up there. But it's just the same thing again. I'm just going to tack that corner first of all. And again, we're not too worried if we get a blob or anything like that, because we can sort it out. And then we'll just double check that it's sitting in position. And so in typical fashion, the battery died in my camera there, just as I was starting to solder that. And I didn't notice until I was finished. So let's just try and show you this one instead. Again, it's really easy to line up by hand. So we'll just get a little bit of flux on one corner. Just tin up the end of the iron. I'm going to try and hold the chip just moved. Then we'll just check to make sure that it's still straight, and yeah, it's not too bad. So we'll just do the other corner as well. Just check it one more time. Seems to be sitting okay. So we can just put our flux along the pins. Bit more liquid metal on the iron, and let's go for it. Those last two pins there, just where I tacked the chip down initially, those are bridged. But a little bit more flux. And that's that side sorted. Same again for the other side. And to be perfectly honest with you, the thing that has made the biggest difference with my ability for soldering this sort of work is the chip quick and this solder. Trying to use the cheaper stuff previously, like when we first built the RGB to HDMI, well, it was an absolute nightmare. Now granted, it was the first board that I had built, but spending that wee bit extra, getting the decent stuff, makes all the difference. So that's the two memory chips on. just these 4 things to do here, and that's all the surface mount work. Okay, got those on, and you'll notice that I've also fitted the 44-pin IDE header. Not actually sure if I'm going to use this or just continue using the IDE that's on the A1200 motherboard. Probably wind up using both, to be honest. Maybe use the one on the motherboard for Workbench and then put a CF card in that. It would be easier to get to that one through the trapdoor without having to dismantle the 1200 every time you want to update the contents of the drive. But that's getting slightly ahead of us. The next thing I want to do is fit this, the edge connector. Now, as I'm sure you know, it's keyed on the 1200, and equally here on this where the pins are, it's keyed as well. You can see a gap there. There's a gap at that point. That has to go on like that. Getting it on though, not sure how easy that's going to be. Just make sure that they're all through. They certainly seem to be. So let's just stick it on. And for this, I think I'll just use some of the cheaper flux that I have rather than using that chip quick stuff. That's a bit overkill for the through hole. Although, while this probably is easier for most people to solder, it is a bit more difficult to tidy up when you're finished. And we've got an awful lot of pins to do, don't we? But once you get into a rhythm, you can sort of almost drag solder this. Just keep the tip well loaded with solder and work its way down over the pins. There's that side done already. Yeah, making a mess. The tip on this iron's a bit big to get in between all those pins. I think my little drag soldering technique there is only going to work for the outside row. For the inner rows, I'm just going to have to do them one at a time. All done. It's covered in flux, but I'll tidy it up in a minute. And I've also stuck a little jumper on there for the enable, which I'm just going to put that on there now, so that I do not forget and then wonder why it doesn't work. But last piece of the puzzle, the socket for the 030 CPU. Now, getting these sockets isn't the easiest thing. So I thought what I'd do is I reached out to Mark, aka SupaDupa, who builds these boards and sells them. I have got some stuff off him in the past, and so dropped him an email and asked him would he have any sockets he would be willing to sell me. And typical Mark, being himself very generous that he is, he sent me sockets free of charge. So we've got 2 030 sockets and then one for the 060. Only need one of these for today. And that has to go on there. Like that. That's it finished. All that's left to do is test it. Need to put the CPU in. I have tried to clean it up as best as I can, just using IPA and cotton buds. Hasn't turned out too bad, but if I had the likes of one of those ultrasonic cleaners with their annihilating rhythms, they would certainly bring this up nice and shiny. But for now, what we have here, it'll do fine. CPU. So I have this 030. This is just the EC variant. This was originally fitted to my TF1230 and then that was changed out for a gold top chip. And I may actually swap this one back into the CD32 and take the gold top and put it in this. Or I might just buy another gold top for this card. But for today, this will do fine. And I think that's the correct orientation. Pin 1 marker there, and it's the same on the silk screen. Tight fit. So we'll pull out the ACA. ACA 1233N. This is a 40 megahertz accelerator with 128 mega RAM on it. One thing I always found odd was that on the silk screen on this, it says that that should be the EC CPU, but it's not. That's actually the full chip is fitted there. Maybe I'll take that off there and stick that one on. Nah, just leave that as it is. But we'll get that out of the way. And let's see if I can get this in. I may have to dismantle the Amiga to fit this, because there isn't a lot of room here for me to get my fingers in. Nope, there it goes. One thing you have to watch on the 1200s is that the edge connector here, it sometimes has a square edge on it rather than a chamfered edge, and it can be really hard to get these accelerators in without risking damaging the edge connector on the accelerator itself. That went on there okay, but we will take a closer look at that in a minute. So I will have to open up the machine to look at that, but we'll have a closer look at that in a minute because it's something I've been meaning to check. But look, anyway, let's test it. So let's get the monitor on. Unfortunately, the switch is broken on the front of this, so I have to wedge a bit of cardboard into it to stop the monitor from turning off. Something like that. And let's see what happens. Is it booting? Looks like it is. Looks like it started. Volume RAM disk is full. What's that all about? Well, we can boot sysinfo here off disk. And maybe use that to see if it's seeing the RAM. I'm wondering, is there something wrong with the RAM? Well, we have got our 030, which, you know, I sort of expected. But it's not seeing any of the fast RAM. So typically, when you have a problem like that, after building a board, it's going to be one of the solder joints. What I've done here, since it was related to the RAM, is I've reflowed the two memory chips, reflowed these four things, and reflowed this side of the CPLD. So fingers crossed that will solve our problem. Let's get it back in the 1200 and see if it works. And I checked this quickly. This 1200 with its revision 2B motherboard, it does have a chamfered edge along this edge connector. Some of them don't, some of them are just a square edge, making it really hard to get these accelerators in. As I said, you can bend the pins on, you know, that slot there if that has a square edge. The only way really to deal with that is to try and file it down very, very gently. You would need to, you know, put masking tape or something on that and then just file it down with a metal file, just very gently on the edges to create the chamfer. And all that chamfer does really is help guide these expansions into place. We've still got sysinfo in the drive, so let's just boot into that again and see if we now have the memory. And yes, you can see straight away there, sysinfo has loaded all of its various items there into 32-bit RAM. If we go into memory, there it is. Total size 64 megabytes, memory type 32-bit. And just in case you're interested, there is the 2 meg chip. If we run the speed test now, things should be a bit quicker. 9.59, 9.6. That's about right for a terrible fire 030 accelerator. Fantastic. The only other thing we need to figure out then is that onboard IDE. How do we use that? So you can see I've added a ribbon cable here to the IDE header on the TF1230. Thing is though, the Amiga can't see that IDE just out of the box. What we need to do is load a device driver, and it's ehide.device. So what I've done is I've set up a very basic Workbench 3.1 installation on this SD card. We have the device driver on that. So if I just connect it up here, and if we just boot into Workbench, what we need to do is to create a bootable floppy. We'll stick the device driver on this, get the Amiga to load that. Then if we do a soft reset, it should see the IDE on the TF1230 and boot off that. So I just have a blank disk here. And to make that disk bootable, we need to go into Shell and type install TF0. That's it. We'll then just use Dopus to copy a few things onto it. So from DH0 onto DF0. In fact, in here, what we'll do is we will create a directory. We'll call it C. We'll make another one, call it devs. And we'll make another one, call it S. So in C, from DH0, we need to copy load module. Where is it? There it is there. Then into the devs folder, we need to copy the ehide.device. Then we need to create a startup sequence, so I need that shell back up again. We'll just go to the appropriate folder on the floppy drive. And within this startup sequence that's going to reside in the S drawer on the floppy drive, we need to load module. ehide.device. But just before we test it, I want to jump into sysinfo here quickly, just to see how fast that SD card is connected through to the IDE on the A1200's motherboard, and we can compare that then to the TF1230. So connected to the motherboard, it's getting about 2.1 megabytes per second. Right. Amiga off. I'll pull that out of there, put it in here. That's one thing, by the way. I might have to get a slightly longer ribbon cable. I know you can't make it too long because it's not a buffered IDE, but maybe get one that's slightly longer. Then I could maybe get it wrapped in around the back of the board so that I can access this from underneath. But for now, just for testing purposes, we can sort of balance the keyboard in there like that. Just going to remove the disk for now. And when we power on here, the Amiga should eventually just post to its kickstart screen. And there it is. So, didn't boot to that, but we stick the disk in. Okay, that should be it loaded. So we can eject the disk again and just do a soft reset. And now, fingers crossed, it boots to this. And yes, it has. So let's see how fast that is now. Back into sysinfo, drives, DH0 and speed. It was 2.1 roughly before, and now it has jumped to 3.2. So that is quite a bit faster. But to be perfectly honest with you, at the minute, I don't think I'm going to use this. Yes, that is going to be faster, but I think I'll just continue to use the IDE up here with this thing, the old spinning hard drive, and purely because of the hassle having to boot to the disk first. Now there is a way around that, and it's something that I'll look at in the future. What you can do is create a custom set of ROMs with that ehide.device built into these, so that when the Amiga boots, it will have that device driver on its ROM and it can boot to this straight away. I couldn't be 100% sure, but I think if you had a drive here and a drive here, even with that device driver loaded, I think the Amiga will default to this IDE first. Not 100% sure on that, so if anyone knows better, please let me know. Well, I think that will do us for today. We have successfully built our TF1230. Although I'm not just finished with this card yet, I do want to revisit it and take a look at those ROMs on the A1200. See if we can build that EHIDE.device into those ROMs. It'll be very similar to what we did when we built the IDE 68K. Remember, we made the custom 1.3 ROM? Well, it's going to be the same sort of thing, but this time with 3.1. And the other thing that I want to try and do you remember when I got the TF1230? That's the 030 accelerator for the Amiga CD32. Well, it was 50 megahertz, the same way this thing is, but we were able to overclock it slightly to 54 megahertz. I still have a couple of those crystals lying about, the 108 megahertz, and I have a couple of the 120 variant as well. So, you know what I'm thinking? Can we swap out that? And can we get this card pushed out to 54 or even 60 megahertz clock on the CPU? But we'll leave all that for another time. As for this video, if you enjoyed what you've seen, I would appreciate a big thumbs up. Why not hit subscribe if you haven't done so already? Still plenty more yet to come here on CRG, and I'll see you next time.